torsional frequency of multiple shaft. So we will use the um, Holzer methods for multiple shafts for finding the torsional frequency. So these are the steps that need to be followed up for the Holzer methods. So first of all, calculate the equivalent shaft system with reference to any convenient reference shaft. Let's say shaft 1 is a reference shaft. And after calculating the mass moment of inertia of disk and shaft stiffness. Converting shaft in equivalent system means making the shaft speed same as reference shaft speed. Assume angular frequency omega by trial and error. Assumption of angle of twist for all the shaft disk except last segment shaft such that angle of twist at common junction point should be same. Calculate torque for all the shaft segment except last shaft starting from free end to common junction point. For the last segment shaft, a starting point shall be from common junction point to free end of the disk. A starting angle of twist for the last segment of shaft will be equal to angle of twist of the common junction point, and a starting torsional torque of the last segment of shaft shall be summation of all the torques at the junction for all the remaining shaft segments. Then calculate angle of twist and torque at the last segment of the shaft at free end. If the residual torque at the free end is 0, then assumed frequency is the torsional natural frequency. Similar procedures to be followed up for higher natural frequency by assuming higher angular speed. Mode shape of torsion natural frequency is plotted on length of the shaft versus angular displacement. Now understanding with an example how torsional frequency is calculated for multiple shaft. This refer picture above where a speed ratio is given to N2 by N1. For shaft 1, mass moment of inertia is given 5, mass moment of inertia of gear is 13, torsional stiffness of shaft is 2.5 into 10 to the power 4, and distance between disc and gear is 0.4 meter. For shaft 2, mass moment of inertia of disc 2 is 1.5, mass moment of inertia of gear IG1 is 3, and torsional stiffness of shaft 2 is 1.125 10 to the power 4, and distance between gear and disc 2 and gear, this one is 0.4 millimeter, 0.4 meter. Now we have to first convert in equivalent system with reference to shaft 1. So equivalent gear IG plus IG1 into N2, which is coming 25, equivalent mass moment of inertia of disk, which is coming 6, and torsion stiffness of shaft 2 is coming 4.5 into 10 to the power 4. Now first torsional natural frequency is coming as 74.3195 radian per second, which is equal to 11.8 Hertz, and this is a mode shape for the first torsion natural frequency of group of shaft. This is the second torsion natural frequency, and it is coming as 98.8768 radian per second, and it is equal to 15.7 Hertz. And this is the mode shape for the second torsion natural frequency. So hope you have understood how the torsional frequency is calculated for multiple shaft system. First of all, you need to convert in equivalent system mass moment of inertia and equivalent system for shaft stiffness, and then use the Holzer methods to calculate the torsional torsional frequency of multiple shafts. So thank you for watching.